Afternoon, everybody. Don't know though, I'm delighted to see some people still here at this time of day. So well done, everybody, and hopefully you'll see something of interest. Right, so anybody who's been to some of these presentations over the last few days, we've seen some really great systems and ideas coming through, lots of discussion about AI and road condition monitoring. One of the things that I think we need to remember about what we're doing here is where are we going? What are we trying to achieve? And where I think we really need to be going as an industry is to getting away from the reactive maintenance elements of what's turned into repairing potholes, and there's been lots of excitement about that, and even the Prime Minister standing up and talking about fixing 7 million potholes this year, etc., which of course we're no nonsense on the face of it. What we really need to be doing is driving towards preventative maintenance. I'm passionate about that, and what I'm about to show you, I hope, is going to help in your efforts to do that. Because in order to prevent potholes filming in the first place, and us getting out of that cycle, we need really good quality information, because we know exactly how potholes form. We know it's cracks, we know it's water getting in, pumping, hydraulic action, frost, etc. But where are the cracks? How do we know that? There's too many defects on our networks to possibly be able to manage manually, or is there? So just to give you an idea of who Robotized are, so there might be a new name to you. So we're a relatively young company, a technology spin-out company from Liverpool University, and our intention is to bring AI, autonomous vehicles and laser scanning into our industry in a way that's usable for highway authorities. So I'm going to talk to you mostly about that is phase 1 of our journey here, which is miniaturized laser scanning. So laser scanning isn't new, of course. It's been used for a long time, but in this format it's miniaturized so that it can be attached to existing vehicles and done more often and readily than it's currently done. By phase 2, for anybody who was here last year might have seen our electric autonomous crack repair robot working outside, created lots of interest. That's prototype at the moment, so I'm not going to dwell too much on that. But ultimately, if we understand where the cracks are on the network and we can treat the cracks, we can stop the potholes filming and we can get ahead of it in that way. And then phase 3 for us, ARRES Ultra, is ultimately a completely autonomous pothole repair robot. But if you think about it, if we get phase 1 and 2 of this project right, we could kind of make phase 3 not required. And that really, from an industry point of view, from an engineering point of view, is where we're trying to get to. So, within the industry, thanks to the RSTA for this graphic at the bottom here about asphalt degradation curves, we see these quite a lot, don't we, in the industry? We know that asphalt starts well, and it degrades over time. We know how that works. And it's all about where do we intervene. So in this particular example, it's showing an intervention at around year 8 with surface dressing. So we know the asphalt will be getting distressed. It's cracking. We're going to intervene with surface dressing. We're going to stop the rot, so to speak. But I would argue that a lot of those curves are actually quite theoretical. I believe that by only scanning once a year, and perhaps not even that often, we don't really have enough data points to draw those curves. And I would suggest that different asphalt types, for example, HRI may be quite significantly different than SMA, and even in different parts of the country with different weather conditions, our asphalt may deteriorate in different ways, but we simply don't have the numbers. So as asset managers, to decide where you're going to intervene before it gets to potholes is quite a difficult decision. So we know if we do nothing, the cracks will decay into potholes quite quickly. So how do we get around that preventative maintenance? How do we track deterioration? So the ARRES EYE, which is our first product, is about enabling you to scan the network more often and get quantitative data. So there's lots of information out there already in different formats. There's a lot of visual data currently, and we're not focusing on providing visual data. There's plenty of other people doing that. What we're trying to provide you with is quantitative data. So not just the fact that there is a pothole at that location, but exactly how deep is it, how wide is it, how long is it, what's the volume of it, and is it changing over time? So if, for example, you've scanned the network and seen that there's a defect that's 20 millimeters deep in one location, that's probably not at your intervention level. That's probably something that we're going to keep an eye on, a watching brief as it were, but not something we're going to deal with immediately. Whereas if you've got a pothole that's above your intervention level, then you may want to do to get on with it exactly. So we're scanning and providing that millimeter accurate detail at 60 miles an hour and a full lane width. So nobody's getting out of the van in order to get those type of measurements. We can identify potholes, cracks, ironworks, rattling, that type of thing. All of the common defects that we would see, localize them on a map of course. But it's that three-dimensional measurement which is setting this apart from just visual data. What we are then doing, so we just heard somebody talk about not using AI, but we're proud to be using AI, which we developed at Liverpool University to then process all of that information, because a lot of local authorities have said to us, data is great, but don't bury us in data because we haven't got the people to be able to analyze it. And are we actually in a worse condition if we've measured all of this and we knew it was there, but we didn't do anything about it? So what we're trying to do is process that data in a way that you can see the important bits. So if you're saying this particular depth of pothole is important to us, but we're not too interested in the ones that are shallower than that, we'll show you those. Also different from just visual data is this is unaffected by light. So if you're trying to collect visual data, for example, on a day like today, it's very sunny. You go down a rural lane. I live in Cheshire, so you can very much get into that daylight, shadow thing. Trying to spot a crack or a depth of a pothole in those conditions is challenging. This is a laser, so it's beyond the visual spectrum, so you're not seeing anything actually happening on the road, but also it's unaffected by light. So if you're in a dense urban area, for example, it might be better to do this at night, and it's unaffected by it. And one of the big differences here, so we've just seen Castle talking about doing surveys in a similar way. We actually provide this tech so that you can attach it to existing vehicles that might already be on your network. So if you've already got highways inspectors out there, for example, perhaps they're doing a CVI survey driven, what they could be doing is collecting quantitative information at the same time by attaching one of these to the back of the van. Takes about 20 minutes to retrofit any vehicle. There's no hard wiring involved. So you can, if like some of the authorities have got quite a few inspectors' vans, so you can perhaps move it around the fleet and get different parts of your network. And you would end up with looking something like this. So this is our user interface. So you can see the route that's been driven there. Up at the top left, you can see the number of potholes we detected, number of manholes, the amount of alligator cracking, transverse cracking, longitudinal joints, etc. So all the features that you might expect. On the right here, behind me, which you probably can't see very well, you can drill into then every defect in there. So if there's a pothole you particularly want to look at drilling, you'll see exactly the dimensions of it. We rate those on a 1 to 5 scale, depending on their severity. So if you decide you only want the most severe, then just click on those and it'll give you a list of all of those. All of that is happening in near real time. So if the inspector's out today, that information is being beamed directly from the ARRES EYE to the cloud. We're processing it in the cloud using AI, and that's coming back down to your desktop. So we're expecting those answers today or tomorrow, not in a few weeks' time. So again, if it's potholes and it's something that you need to address quickly, you'll have that information right away. But a number of authorities have also said is that we already use XYZ software to manage our assets. We don't really want another place to look. So can you provide your information as another layer of information inside our existing asset management system? So last year when we were here, we met Brightly with a Confirm system. We met Imagery with their system. All the systems are available. This last left one out. So we've worked with them. It's actually not too difficult for us to provide the data in a format which feeds directly into there. So rather than use our system, this is an example from Confirm as it happens. So our information has been threaded into there and superimposed on what's already in there. So if you've already got background information in there on your asphalt types and your maintenance, etc., this is another layer. Again, it's worked through those exact dimensions and exactly where it is. So this is perhaps a good example. So this is on that map that we have there. There's a pothole identified on that particular stretch of rural road. And this is what it looks like. So the first image there on your left is a normal optical image. So you can see that there's something on the right-hand side of that image. So there's a defect there without doubt. It's difficult to tell how deep though, because it's just a photo. So the image in the middle is the laser scan. That's a depth map. And the way that works is that the darker the image, the deeper it is, basically. So, and then on the far right, which you might not be able to see too well behind me, is what the AI then has. We've taught the AI to look for potholes, and that's categorized that as a pothole. And in that particular situation, it's 71 millimeters deep. So it's a cat run defect that we need to do something about straight away. What's interesting about working with systems like Confirm and Imagery is, as you're already aware, they can already create a work order. So we can take our data directly through. If you say anything over 35 mil, we want to deal with straight away, it can feed directly through and create a work order and send somebody out without any human intervention. If you want to use it in that way, you can keep it so that you decide what you want to do with the information. So it's easy to adopt, fit it to any existing vehicle, move it around if you want to, plug and play, no special wiring. Your inspectors, whoever is out on the network already, so it's not an extra vehicle movement. Guys are already out there, they have to be. So scan it 60 miles an hour, 3D measurements, everything is geotagged, nobody's getting out of the vehicle for any reason, and you don't need a second person in the cab either. This is all automatic. And then view it either through our interface or through one of the asset management system that you're already using, and you've got all of that in near real time. So what are you going to do with all of that? So once you know accurately where these defects are, the beauty of doing this is that because it's much lower cost and it's not a specific survey that you're buying into, if you've got this on your inspectors' vehicles, you can be getting scans of your network more regularly. So we talked about those deterioration curves and lack of data points. Now you can actually start to see over time that deterioration happening on your network. So if you've got a section of cracked road, for example, that you're keeping an eye on and you see those cracks start to deteriorate, you know that come the winter it'll be potholes. So you can decide to intervene. Alternatively, if you've got a section of cracked road and it's not really changing over time, then just keep an eye on it. That's all you need to do. So for the first time, I think we're able to track and see that cracks aren't forming in that network. And similarly with asphalt reinforcement or premium binder mixes, all those types of treatments or extra materials that you might have bought into, check them over site. So hopefully that's giving you better information to provide you what you need for asset management planning and to get ahead of the whole pothole thing by preventative maintenance. And that's what we're looking to provide. So, are we got any time for questions, or is it exit stage left?